The limit that turned out to be fundamental. At first, it looked like a technical problem, something engineers would eventually solve, a barrier waiting for better tools. Every era of physics had faced limits like this before. Materials failed, energy ran out, precision hit a wall, and every time progress pushed past, limits were challenges, not truths. The history of science was, in many respects, a history of overcoming boundaries that had once seemed absolute, and that history created a deeply ingrained expectation that no limit was truly permanent. To understand why this one mattered, we need to revisit that confidence. Nature had always yielded to effort. With sufficient ingenuity, sufficient resources, and sufficient time, every previous barrier had been circumvented, reduced, or eliminated. The pattern was so consistent that it had become an article of faith within the scientific community. Faster machines, stronger fields, sharper measurements. If something could not be reached, it was assumed to be temporary. But this limit behaved differently. No matter how technology improved, it refused to move. Pushing harder did not help. Refining methods did not help. The boundary stayed exactly where it was, unchanged by ingenuity. Every approach, no matter how creative or technically sophisticated, encountered the same ceiling at the same point, as though the limit were not a property of any particular system, but a property of reality itself. At first, physicists treated it as practical, a limitation of current understanding. Surely a deeper theory would loosen it. Surely nature would not enforce a hard ceiling. But every new framework preserved the same boundary. Classical models hinted at it. Relativity confirmed it. Quantum theory respected it. The language changed, but the limit remained. Each new theoretical framework, despite revolutionizing the understanding of everything else, preserved this particular boundary with perfect fidelity. It was as though every theory, regardless of its starting assumptions, converged on the same conclusion. This was the first warning sign. Limits that survive paradigm shifts are not technical. They are structural. They are telling you something about how reality is built. The realization arrived slowly. This was not a problem to be solved. It was a feature to be understood. The universe was not blocking progress out of stubbornness. It was enforcing a rule. And once that rule was recognized as fundamental, the meaning of limitation itself began to change. At first, physicists tried to treat the limit as negotiable. Maybe it could be bent, approached arbitrarily closely, circumvented with clever setups. History encouraged that optimism. Almost every previous limit had eventually softened, but this one refused compromise. As systems approached it, the rules themselves pushed back, not with resistance, but with transformation. Time slowed, lengths contracted, energy poured in without yielding progress. The universe did not simply resist the approach to the limit. It actively transformed the conditions of the approach, altering the fundamental quantities of space and time to ensure that the boundary could never be crossed. The closer you came, the more reality changed to stop you. This created a deep conflict with intuition. Limits were supposed to arise from weakness. This one arose from strength. It was enforced by the structure of space and time themselves. The fabric of reality bent and warped to prevent violation, not as a secondary effect, but as a primary feature of how space and time were constructed. As understanding deepened, the limit revealed its purpose. It protected causality. It preserved order. It ensured that the sequence of events, the fundamental narrative of reality, could not be scrambled by brute force or clever manipulation. Without this limit, the concept of before and after would lose its meaning. Without it, effects could precede causes. Information could arrive before it was sent. Reality would unravel into paradox. Emotionally, this was humbling. The universe was not an open playground. It had guardrails, boundaries that could not be crossed because crossing them would destroy coherence. By this point, the limit no longer looked arbitrary. It looked necessary. It was not preventing progress. It was preventing contradiction. The universe was not saying no because it lacked generosity. It was saying no because it valued consistency more than possibility. And that realization was pushing physics toward a final conclusion about what limits really mean. The conflict sharpened when physicists realized this limit was not merely about motion or energy. It was about information, about how quickly cause could become effect, about how fast the universe could update itself without breaking its own logic. This buildup revealed a deeper pattern. Every time physics tried to imagine a world without this boundary, contradictions appeared immediately. Events overlapped, sequences unraveled, explanations failed. The universe stopped making sense. The limit was not attached to any specific object or force. It applied to everything equally: particles, fields, signals. Even space and time themselves respected it. Nothing was exempt. Emotionally, this was unsettling. It meant that freedom was not infinite. The universe allowed change, but only up to a point. Beyond that, structure collapsed. Possibility gave way to nonsense. The scenarios that emerged when a limit was hypothetically removed were not merely improbable. They were incoherent. They described universes in which no consistent description of events could be maintained. As theories grew more abstract, the role of the limit became clearer. It was not a parameter that could be adjusted. It was a condition for having a universe at all. Without it, there could be no consistent history, no reliable memory, no stable reality. By this point, the question was no longer why the limit existed. It was why anyone ever thought it might be negotiable. The universe was not reluctantly imposing it. It was built around it. The limit was not an addition to the laws of physics. It was woven into their foundation, a structural element without which the rest of the architecture could not stand. Every equation, every principle, every conservation law assumed its presence. The climax of this story is a reversal of ambition. The limit that turned out to be fundamental was never a wall blocking progress. It was a frame holding reality together. Once this is understood, limits stop feeling like failures. They become definitions. The universe is not infinite in every direction because infinity without structure is meaningless. Boundaries give form. Constraints give coherence. This insight reshaped how physics thinks about possibility. Not everything that can be imagined can exist. Reality is not obligated to realize every scenario. It must remain consistent. The limit enforces that consistency relentlessly. More deeply, it reshapes humility. Mastery does not mean removing all constraints. It means understanding which constraints are negotiable and which are foundational, and directing effort toward working within the ones that define the boundaries of what is possible. It means working within the ones that make existence possible. Freedom without structure is not freedom. It is collapse. Today, this fundamental limit quietly governs everything from particle physics to cosmology. It shapes how information flows, how time orders events, how cause and effect remain meaningful. No theory has ever replaced it. None ever will. The limit that turned out to be fundamental was not discovered by pushing past it. It was discovered by noticing that it never moved. And once that is seen, the universe stops feeling restrictive. It starts feeling carefully constructed, a universe that chose consistency over unlimited possibility. And in doing so created the conditions for structure, complexity, and understanding to emerge from what would otherwise have been formless chaos. Subscribe to join the journey. The